So it's pretty unfortunate in vectors that there's a repeat of symbols from, I'm going to say, air quotes, regular math. So, and I actually air quoted there, and I don't know why because you can't even see me. So the problem is there's these two major calculations that you have to do in vectors, especially the Cartesian vectors. One of them was dot product, and we looked at that before. And the dot product has two vectors indicated with your vector symbols, and it's got a dot. And dot is, before this note, a couple of notes ago, was multiplying. So it looks like multiplying, but actually it's got a formula. And here is the formula. The other formula, in case you aren't given an angle and magnitudes, the other formula, just a reminder, is the x's multiplied together, the y's multiplied together, and the z's multiplied together if you're in 3 space, and then adding those up. So both of those are dot product calculations. And remember that these pieces of information are not coordinates, they're components, which is why this is what's used for dot product in component form, and this is the formula that you use for dot product when you're given an angle between two vectors. So if we go back to cross product, which is today's note, or this note, that didn't work out well. You've still got components, only this time, because I'm trying to match future textbooks of your life, instead of the x component, y component, and z component, which is what these are, I'm calling it A1, A2, A3, and with the vector b, B1, B2, and B3. The symbol for cross product is the regular old multiplying sign. And the deal is you don't actually multiply vectors. You only do dot products and you do cross products. So that's why they repeat symbols that you're used to in other places, but it means something totally different. So let's try to get this formula, and then I will explain what you're doing. So right now it's just how do you use the formula. I am going to do this question twice, as in I'm going to do question 1 twice. I am moving question 2 out of the way. Don't spoil the surprise of what a cross product is. Don't look, don't look, don't look, don't look. There. Whew. So there's the formula. And I'm going to leave this there so we can see which component is A1, which component is A2, which component is A3, and the same with the B's. But A cross B is taking the second A and multiplying it by the third B, and then minusing the third A times the second B, and then going on to create a second component and going on to create a third component. So the first thing I'm going to do, because it makes me a little more comfortable, is I'm going to call these things what they are according to the formula. So this, oh, I didn't want to use blue. I'm going to use green. This is my A1, this is my A2, this is my A3, this is my B1, this is my B2, and this is my B3, and I'm being asked to determine U cross V. So it doesn't really matter what these vectors are called as long as you know what the pieces are called. So, do it in red just for fun. So method 1, I'm going to show you, is the formula. So U cross V is equal to, let's see how neat I can be. So the second A, -1, multiplied by the third B, that's 4, minus the third A, in a bracket or out, multiplied by the second B. Big comma. Next part, the third A multiplied by the first B, subtract the first A multiplied by the third b, big comma. Last one, or last piece of this formula, the first a multiplied by the second b, subtract the second a multiplied by the first b. Okay, so now I'm going to figure out all these pieces. So square bracket here. This is -4, subtract 15, big comma. This is -6, subtract 24, big comma. This is 30, subtract, this is +2. So if you get a negative, negative, you end up adding. And then to calculate the end result of u cross v, its components, -19, -30, 28. So as you can see, cross product, I was going to say, is not a scalar. Cross product is a vector. And I'm going to call this method 1. And method 1, I'm going to say, is the formula. Now, the problem for me when I was in high school is that I could never remember this formula. I mean, it's a whole lot of stuff, and my brain just won't fit it. Before I forget and show you the second method, I do want to draw your attention to the fact that cross product can only happen in R3, so you have to have 3 components per vector to pull this off because of this formula. All right, so let me show you a second way. Now, I'm going to show you a second way that's side by side. I have seen a second way that is up and down. If somebody shows you a different way, that's totally okay, as long as you end up with the same answer, which is components -19, -30, and 28 here. So this method, I don't have a special name for it. I call it the Scribble Method. But it pulls off the same thing as long as you do it properly. So the first thing you do, and this is scribbling, so don't think I'm finding the answer right away. So the first thing you do is you write the first vector, so the u, twice across your page sideways. And like I said, some teachers will teach it to you up and down. And then on the bottom, you put the second vector, which in this case is v, sideways, twice. And you try really hard to keep things lined up. So this might sort of kind of remind you of synthetic division, but it's not, because it's vectors. And then what you do is you wipe out the first set of numbers and you wipe out the last set of numbers. Okay, so now it's set up to do our math. So isn't it lucky that you're sitting here watching this? Because without my voice, this note or this part of the note would probably not be super useful to you. Okay, so what you have to do is you have to do right, left, right, left, right, left, right, left until you're out of stuff. So by that, I mean right, and you have to figure out that value, subtract, left, big comma, right, subtract, left, big comma. right, subtract, left. So the answer to vector u cross vector v is the same as what we have above, because this is negative 19, this is negative 30, and the third component is 28. And I don't have a formula to remember, I have a process to remember. So I'm going to put here right minus left, and I'm actually going to turn that into an arrowhead in case you think it's a minus sign. So that's what you do to figure it out, and I like that so much better. So I will continue with this process because, to be honest, I've never been able to memorize this. I might have memorized it for 5 minutes before a test one day, and then I gave up, and I learned the Scribble method. All right, so let's look at the second question, which is pretty much the same thing, only another chance to practice. Okay, and we'll look at this red thing in a second. So the question says, determine the components, so determine the x component, y component, z component, of a vector that is perpendicular to both a and b. So I wish I had my camera on, even though I'm kind of glad I don't have my camera on because I don't know how well I'd be at describing this. But if you've got a vector that's sitting on your page going in that direction, and you've got another vector going in that direction, so that's 2 space. If you pull that back, so any 2 vectors are 2 space, the third vector would be poking us in the eye, and that vector would be perpendicular to both of these. So it would be 90 degrees coming out of the page at us, and I'm pulling up my pen doing that, and then it would be 90 degrees to this vector at exactly the same time. So it would be perpendicular to both vector A, let's call this one A, and B. So it would be poking us in the face, and that would be perpendicular to both of these. And that's the cross product. So if I ask you for the cross product, and I ask you for a vector perpendicular to 2 other vectors, that is the cross product. Same deal. So what I'm going to do is I'm going to get these vectors out of the way because they don't really demonstrate anything useful. And I'm going to set up to do my scribble because all I have to do here is a cross product. So the cross product is a definition, and it's right here in red with the double stars. So let's do our same thing. The first vector is A, so 6, negative 2, 3, 6, negative 2, 3. The next vector is B, negative 4, 7, 1, negative 4, 7, 1. Scribble out the first, scribble out the last. Now, I like to just do that because it doesn't make me think about what I need and what I don't need. I just write everything down and then scribble out what I don't need. But yes, of course, you can do 2, 3, 6, 2. Sorry, negative 2, 3, 6, negative 2. But I find that difficult and I overthink things, so this is my best approach personally. So now I'm going to actually do the calculations, same as above. So, green. I'll do both at the same time. So right first, minus left, comma. Right first, minus left. Right first, minus left. Be careful with these signs. Minus 8. So, A cross B, vector A cross vector B, is negative 23, comma, negative 18, comma, 34. Which doesn't really answer the question, because the question didn't ask us for cross product. Exactly. It said, determine the components of a vector that is perpendicular to both of these other vectors. So I can now say the actual answer, which is a vector, and I'm going to remind you of a symbol, a vector perpendicular to both vector A and vector B, is this vector that we just created using the cross product. So the cross product and this perpendicular vector are exactly the same thing. So I do want to tell you that I sort of lied to you when I had those two vectors on the page, and I said that the vector was poking us in the eye. It's poking us in the eye, so I didn't really lie, but there's a second vector. So a second perpendicular vector, can you guess what it is? Positive 23, positive 18, negative 34. So this is the opposite of poking us in the eye. This is poking us away from our eye. So it's just this vector with every single sign change. Don't miss a spot. Now, I do want to remind you that there is a way that you can check your work, and I'm going to check it with this one, just so you know. Because I don't want you to lose the fact that all this stuff kind of fits together. We've got a vector 6, negative 2, 3. And we have created this vector negative 23, negative 18, 34. And apparently, if two vectors are perpendicular to each other, their dot product should be 0. So how about I check the dot product of that? Now, I do want you to know that I plan on checking the second vector as well. So there was vector A, that's this check, and there's vector B, just so I know if my answer is correct. So 6 times negative 23 is 8, carry the 1, 12, 13, negative 138. And then I add that to negative 18 times negative 2, which is a 36. And I add that to 3 times 34, which is, ends in a 2, carry the 1, 102. And this is positive 138, and this is negative 138, so that's 0. That works out. So let's try this one. See if it's also perpendicular. So negative 23 times negative 4, or negative 4 times negative 23, whichever the case is. And that is 2, carry the 1, so that's 92. Plus 7 times negative 18 will be a negative. It'll end in a 6, and it'll be 126. And then add that to 1 times 34. Whew, that one's easy. So if I take 92 and 34, that's 6, it's 126. And here's a negative 126, so that's a 0, and it is in fact perpendicular. So this vector here with my star is in fact perpendicular to both of the original vectors, which is what I was aiming for in the first place. All right, so there's another formula for cross product. So there's obviously this ugly one that I gave you where there's, oh, I don't know why that keeps happening, where there's obviously a massive formula and you can get away with a method of doing it that is not a massive formula. But here's another formula. We'll get to it in a second. So the formula for the cross product of two vectors, again, only in 3 space, and their cross product is a vector, so I've said all that stuff. And the last thing is this. Here's the formula. And it looks an awful lot like the formula for dot product, but this one isn't giving you a vector, it's giving you the magnitude of the vector. So if you are finding A cross B, this formula doesn't give you A cross B, it gives you the magnitude of A cross B. And you'll need the magnitude of A individually, you'll need the magnitude of B individually, and you'll need theta, and you'll have to do sine theta, where theta is the angle between A and B. And like I've already said, the cross product gives you a vector that is perpendicular to both A and B. So if it's asking for direction and magnitude, then you're looking for cross product, which gives you a vector. And remember that dot product is a scalar. All right. So here's an example that uses these formulas. And I hope you recognize this number right here from the unit circle. If you are uncomfortable with 3 pi over 4, then you need to take 3 pi over 4, multiply it by 180 over pi, and get yourself 135 degrees. Excuse me. Oh, I can't believe I didn't catch it again. Sorry about that. Okay, so both these questions are asking for magnitude, so it means that I should probably use this formula right here. And in addition to that, I haven't given you any component information. I've given you the magnitude of u and the magnitude of v, and I've given you the angle between it. So it's perfectly set up to do this formula. So I'm going to do one of them in red and one of them in blue. So the one in red, I'll steal the formula from up above. And you can use 135 if you want. And you get that. And the magnitude of u is 8, and the magnitude of v is 17. And if you check your unit circle, the answer for the sine of 3 pi over 4 is root 2 over 2. And if you multiply all those together, this 8 divides by the 2, so you get 4. So 4 times 17 is 68, and then you've got this root 2 lingering. So that is the magnitude of the vector that is perpendicular to both u and v. Now if I change colors, just because I've got a different question, this one, the magnitude of v cross u, is this. And I hope some of you look at this and say, hold on a second, that's not any different than what we just pulled off. Let me make my 4 look like a 4. And it's true. The magnitude of v is 17. The magnitude of u is 8. And the angle between them is still 135 degrees, or 3 pi over 4, which I'm using with the sine ratio. So that's 17 multiplied by 8 multiplied by still root 2 over 2. So 8 divided by 2 is 4, times 17 is 68, still with the root 2. So you get the exact same answer twice. And this should not be a surprise, because if I ask you for the magnitude of a vector that is perpendicular, you should get the same one, because your cross product answer would just be, wrong one, same numbers but negatives. So when you did your formula for magnitude, it would be take the x's, square it, take the y's, square it, take the z's, square it, add them together, and square root. That's the formula for magnitude. So whether you square a 23 or a negative 23, it doesn't matter one bit. Let's see what happened there. I did take care of that. All right, so another 2 questions here. Some purposes of cross product. So here is a parallelogram. I'm just going to move 5 out of the way to give me some space. So give me a sec. It's not well planned. So here is a parallelogram. And I haven't given you any components. I haven't even given you any coordinates. All I've done is I've said that the length of this side is 8 centimeters and the length of this side is 13 centimeters. Now really what I did is I told you that this vector here, whatever you want to call it, has this magnitude, and this vector here has a magnitude of 8 centimeters, and the angle between them is that. So I can use the formula that I just showed you, the one with whatever symbols you choose to, but definitely sine theta. So I do want to tell you that this is what you need to know. The area of a parallelogram is the magnitude of the cross product of the adjacent sides. So if you have this and this, these are adjacent sides, and we can find the cross product of the adjacent sides, so the vector poking us in the eye, and then the magnitude of that, we have the area of a parallelogram. So I'm going to do this symbolically first. So the first thing I'm going to do is I'm going to say that, and I'm going to say that this is the magnitude of vector A, and this is the magnitude of vector B. So now I've designated an A and a B, and I can pull out the formula for cross product, magnitude, and the formula for the area of a parallelogram. So A, magnitude is 8. B, magnitude is 13. Hate it when this happens. Sine 60 degrees. If I dig out my unit circle, the sine of 60 degrees exactly, without using a decimal, is root 3 over 2. So 8 divided by 2, because I can, is 4. 4 times 13 is 52, and I've still got the root 3 there. So that's the answer for the magnitude of the cross product, which is the same as the area of a parallelogram. So I can say area of parallelogram, legal short form in math, equals 52 root 3. Now we can do better than that, and the reason we can do better than that is because I actually gave you units here, and you know how to do area if you think about it a little bit, and that is centimeters squared, and we have our answer. All right, last question, I believe. And there's some nitpicky stuff about this last question. The first thing I'm going to do is I'm going to draw a parallelogram, because I want to show you the tricky business. Let's see if I have one in here. I do. It looks more like a rhombus. Oh, I can make a parallelogram. All right, so here's the news. Actually, I'm going to move this out in space a little bit. Here's the news about a parallelogram. When you label the corners of a parallelogram, and I know I said this if you were in my grade 10 class, when you label the corners of a parallelogram, you can start anywhere you like. So I'm going to put A here. And because I like all my information on the picture, it's 1, 1, 1. B could be here. Here's where it gets tricky. You must pick a corner to start with. So I did. I picked A. And you have to go around. So what that means is that when we go to label C, you can't do a zigzag. You have to start, and that puts C here, which is 1, 2, negative 3. And that forces D to be here. And usually, I start A in the upper left-hand corner, so I usually start A here, but it doesn't have to be there. What does matter is that you don't do any zigzags, so you don't put A, B, C, D. You have to start, and even if A was here, A, B, C, D. You'd have to go in that circular pattern. And that makes a huge difference for how to calculate the vectors, because right now, I don't know if you noticed this, it's all round brackets, which means I have given you coordinates, not components. And we can't find the area of a parallelogram without vectors, according to that last formula. So I'm going to pick a corner, and it doesn't matter which. I may have the same one. I may have a different one, but I'm going to pick vector here, which forces my second vector, poorly drawn, to be right here. So I'm going to call this one vector u, and I'm going to call this one vector v, just for fun and trying to keep it away from the letters on the picture. So the thing about vector u, and I'm going to do some scribbling over here, vector u is actually vector d to a. Start at d, go to a. And when you do that, you have to make sure that you subtract backwards. So I'm going to go 1, 1, 1, 4, 3, 2, and I'm going to subtract. So -3, -2, -1. That is the components of vector u. Now I'm going to do the same thing for what I've decided to call vector v. So vector v is start at D, go to C. So that means when I go to figure out the components of this one, I'll have to write down C first, because that's where I ended with 1, 2, -3, and then 4, 3, 2, and then I'm going to subtract, and I'm going to find the components for vector v. So -3, -1, -5. So now I have a vector u, and I've got a vector v, and I can do the cross product. So this is my scribbling. -3, -2, -1, -3, -2, -1, -3, -1, -5, -3, -1, -5. Scribble, 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 scribble. 10, subtract +1. Three, subtract 15. Three, subtract 6. So u cross v is equal to 9, -12, -3, which is not the answer. That's the answer to a vector that's poking us in the eye or anti-poking us in the eye. What we need to do, now that we have the cross product of the adjacent sides, is we need to find the magnitude of the cross product of the adjacent sides. So, magnitude of u cross v is equal to 9 squared, -12 squared, -3 squared, add them together, square root. So yeah, all the formulas I've given you so far are kind of piling together. And remember, whether you square a positive number or whether you square a negative number, it's always a positive result. So I get that. And 81 plus 9 is 90. And 90 plus 144 is 244, so 234. That was me doing a whole bunch of mental math. And just checking with my calculator, I want reduced radical form. So 234 divided by 4. No. 234 divided by 9 is the next perfect square. 26. And 26 is 2 times 13. So this is root 9 times root 26. I can take the square root of 9. I cannot take the square root of 26. And I did not have units on this thing. I just had coordinates to begin with. So I can't put centimeters squared for area, but I can put units squared. And this is the area of parallelogram A, B, C, D. All right, I'm at the end of my page, judging from this. So here's the stuff from your book. Can you figure out why I don't have it split between R2 and R3? Like every other note, I still think I have the dot product note, although blank. Every other note, I've done this. Why is it that we've all of a sudden got to cross product and I don't do that? Do you know why? Cross product is only available to be done in R3. So, this is only R3. All right, cross product done.